So welcome to part 2 of the lecture number 2, week number 3. And today we will talk about some of the member functions that we would like to implement in this video. In the previous demo, if you have remember, we talked about linked list, why we need a linked list, and the rule of thumb, always draw a picture before you code the linked list in any programming language. Then we talked about different data members of our linked list class. We provided a constructor. We provided add front member function, which adds a node to the front of the list. We simulate this process. We then implemented the print member function, the buggy version, and also the fixed version. Then we implemented those member functions in Qt Creator, and we created our first linked list class. And today I'm going to talk about the AddMember function. We want to provide to the client a function which, when they call, will add an element to the back of the list, right? So the end of the list. The usage of the function would be something like this. They will call the add function on the object of the linked list class we created, and they will provide an integer value. And what this function is going to do is add that value at the end of the list, right? So here we have to consider two cases, right? If the list is empty, we want to do something else. But if we have an existing list, the procedure for adding a value to the end of the list is slightly different. So we'll look at these two cases. So let's first talk about the empty list. If the list is empty, then what we are going to do? So we will have to check if the front value is equal to null. That means there is no node in the list. So we'll then create a new node, and then we'll pass the value provided by the client. And then we will initialize the next pointer of the new node, which we want to create, to point to the front, so that we attach the new node to the front of the list. And then this right side of the assignment will be executed first. So a node will be created, value will be put inside it, and its next will be pointed to the front of the list. And then the new operator is going to return the address of that new node, and we will assign it to the front because this new node has now become the front of the list. So if I simulate this process, so if the list is null, that means the front is null, that means there is no node in the list. We will create a new node, we'll put the value, and we'll initialize the next pointer of the new node to point to the front. So the front will be null, of course, so this portion will also become null. And then we will assign the address of this whole node to the front so that the front start pointing to this node. So if we do that, that's how we handle the first case. If the list is empty, we can add only one node, and that is the front and also the last node in the list. Let's talk about the existing list or the non-empty list. In that case, we have to create a new pointer because it's not an array. We cannot just jump to the size -1 index. So all we can do is to create a temporary pointer. Let's call that current, and assign current the value of the front so that current start pointing to this first node in the list, right? And after that, we'll check if the next pointer of this node is null, because if it's null, that means this one is the last node. But it's not null, so we'll update the current pointer to point to the next node. And how do we move current to point to this next node? By assigning the next address of this whole node. So this is the next portion, which is holding the address of this node, which contains the value 2. When we assign the address of this node to the current will be moved, and now it's pointing to the second node. Similarly, We are going to again check if the next pointer of the current node to which the current is currently pointing is null. That means this is the last node, but it's not the last node. So we'll update current to point to this node. Now the next pointer of this current node, when I say current node, that means the node to which the current pointer is currently pointing to. So the next pointer of this current node is null. That means this is the last node. Now here we have to insert the new node, because the purpose of this particular AddMember function is going to be to insert a node at the back of the list or at the end of the list. So when I execute this, we'll then say that update the next pointer of the current node and assign it the address of this new node so that we chain it together. So we'll say current dot next or arrow next and assign the next pointer of the current the address of this new node, the one we just created right here. So when we do that, we will actually create a pointer from this node to that node. So when we execute that, that's it. We are done. We have inserted a new node to an existing list, right? So the difference between the add front and this new AddMember function is that add front does not have to handle any more cases. There was just one thing to do, and that is to create a new node and attach it to the front of the list. But here the situation is a bit different. We have to handle two cases, and by the way, this is not case one, this is case two. Case one is the empty list. So what we did here is we start traversing the list from the front, and we move from node to node until we reach the last node. And once we are on the last node, we have to create a new node and initialize the pointer of this node, which was the last, and with the address of this new node. So we chain them together. And then of course we have to make the next pointer of the last node to be null, because there is no more node to point to, right? So this is the AddMember function. So let's see the implementation, and that is we have to first create a member function called add. It takes a value which we want to put into the node, which is actually the data. We check if the list is null, that means the list is empty, right? When front is null, the list is empty. So we create a new node, we put the value, and we assign the address of the front to the next pointer of this new node so that it points to the front, right? And then we assign the address of this node to the front. So front is pointing to this newly created node. This is the easier part, right? The case which is easy to handle. This one is a bit complicated. So we have to create a current pointer of type list node, which holds the address of the front. So both front and current are pointing to the first node. Remember that current and front are pointers. They are not the actual objects, actual nodes. They just hold the address of the first node in the list, right? So we have to check if the next pointer of the current node is null, right? That means this is the last node. And if it is not null, like in the while condition, while the next pointer of the current node is not null, that means there is there are more nodes to traverse. So we say, okay, I'll update the current, which should point to the next node. And once we actually hit the condition, that means that the next pointer of the current node is null, that means this is the last node in the list. Then we break out of the loop. We create a new node, right here. We create a new node. We put the value, and the address of the new node will be assigned to the next of the current node, right? Current was actually pointing to the last node. So the next pointer of the current node will get the address of the new node. So both of them will be chained. And the new node now becomes the last node in the list. And then of course, because we added a new node to the list, so we have to increment the value of the size variable by 1.